Hello. Good afternoon, everybody. Let's talk about Latvian story, success story, what we are developing. And this is exactly about Lunar Gateway Program, collaboration project. So what is the gateway? This is International Space Station, which will be built, planned to be built quite soon. And four main players, NASA, European Space Agency, JAXA, and Canadian Space Agency, will build this big station, relatively, not very big, but relatively big station, but important what this station will be on the lunar orbit. And there are several models, and one of the model just belongs to European Space Agency. This is a Spirit. And we are today participating in the development of new technologies, which is required specifically for this new mission. So this model is European system providing refueling infrastructure and telecommunication for Lunar Orbital Platform Gateway. The xenon propellant transfer is one of the main elements, and this transfer should also be done actively. That's why such new device as a xenon refueling compressor is required. So it's quite challenging technology. We should provide efficient propellant pumping from low pressure tank, it's 10 bars, up to high pressure tank. But this is the key element of all Spirit refueling system. So this xenon refueling compressor, based on the thermal compression principle, has been successfully developed in cooperation between Space Agency, OHB system, ESA Prime, and our company Allatherm. So where we are today, so based on the common technology readiness diagram, we reach level 6, starting from level 2 2 years ago. It means we finalize engineering models. You see the photos of the models, 2 of them, and we are now ready for qualification. And it is quite important achievement for us. So how project was organized? ESA was the client, OHB system, developer of the xenon refueling system, but Allatherm is responsible for development of the xenon refueling compressor. Actually, this is the heart of the Spirit xenon refueling system. Even this small device is only 2 kilos, will be integrated in, I don't know, maybe several hundreds of kilo system, but without this small element, this big system will not work at all. So, now, a little bit about our company. Company is young, and we still consider it as a startup, founded in 2015, and managed by myself as Chief Technology Officer, and Igor Sushakov, my childhood friend. We started this company with values, respect for people, fair play, inspiration, innovation, and sense of humor, because it's impossible to survive in research and development without sense of humor. All about being the best in thermal management. This is Allatherm, and our mission to lower entropy. This is our team. We are not far from here. It's in Pulka. It's nearby of Kipsala, and this is on the territory of Latvian Technological Park, which is managed by Triga Technical University. And we are very close working together with university and have even common course for the students. This is our people, our team. We just 16 persons, which are capable to do a big work. So today we have 160 square meter workshop, also clean room 160 and 100 square meter office, and different equipment. Actually, what you see here, everything was done in Latvia, so we are just buying the materials. All processing, welding, sintering, brazing, machining done here in Latvia in our company. So you see this is our machine shop, and this is photo of our clean room facilities. We also have some vacuum chambers and furnaces, very specific equipment. We are working in two areas. Today, it is advanced two-phase solutions. First area is thermal management. It is heat loops and heat pipes for cooling of electronics, I don't know, computers, servers, etc. And second is gas thermal compression, which is the story what I'm talking right now. So what we are doing, design and analysis, research and development, consulting, prototyping and manufacturing, and up to testing and qualification. So there are two technologies, but there are a lot of synergy between two technologies. Our original technology is the two-phase heat transfer. It is thermal management, but now we are successfully developing gas thermal compression. And there are a lot of crossing technologies between. That's why we are quite consolidated. I'm just showing you an example of the technology number one, and this is the also space application. In this case, we have Thales, Italy as a prime contractor, and we reached the technology readiness level 5. This is for thermal control of the electronics on board of the spacecrafts. But currently, it seems like they are willing to put this device also to the Spirit. It means we also can run to reach the level of TRL 9 in 4 or 5 years. But what I'm talking today is the gas thermal compression. So this is a very simple principle. I don't want you confused with physics and technical tasks, but it has a lot of advantages. It's one of the main. It is vibration-free, which is very important for space station. It is only high purity, because xenon is super pure gas, should be on board of the station. And it's especially useful if you are pumping such high purity or hazardous gases, as xenon, hydrogen, and others. The principle is very simple. So it means we have the compressor in the middle and two tanks. One tank has this low pressure, another tank has a high pressure. And when you start to pumping, first you have to cool down the compressor, and you have condensation inside. And after you start to heat, and you push out the gas. It means by heating and cooling, you are pumping gas from one tank with low pressure to another one with high pressure. So that's why it is heat exchanger, but very specific heat exchanger, which is used for pumping purposes. So inside of this heat exchanger, we have to put special capillary structure, which we developed here, but very thermally conductive, which should retain inside our xenon during the absorption of this gas. And we have to provide very quick heat exchange, because we are heating up to minus 60, from minus 60 to 150 degrees Celsius in several minutes. And same, we are cooling down in several minutes, 200 degrees down. And you see, we start from this initial design, because it was already TRL level 4, and it's just demonstration the work what we done and work we can do, perform everything. All analysis was also performed by ourselves, and we have the models of the compressor. There are several problems was solved in this moment, because we had crossing of the thermal fluid and xenon pass, and it was not good from the thermal and mechanical point of view. And finally, you see more than 400 iteration was done to reach the final design of the xenon compressor. So we start from breadboard models, and we perform a lot of analysis of engineering models. Next was also vibration, because vibration analysis is quite important. And again, we found several very original, unique solutions for this, like a membrane, which is working like absorber all this thermal and pressure changes inside of the system, because the system should be very light, but suspend up to 300 bars. And this is also analysis of what we perform on the thermal side, and we perform optimization of the system using, in this case, ANSYS as a working tool. Now you see how it looks this compressor inside. This is the capillary structure. This is the copper, but the copper which has a lot of pores inside with very high porosity, 75–80% of the porosity. And this is working as a heat exchanger. Inside of the tube, we have passing of the fluid during cooling and heating. You see different elements and how it is built. Now it is assembly, and again you see it's a very special steel is used in here. Same, the fiber what we use also very specific, and the processes what developed during the process are unique. And we perform all welding, and now we are working on the qualification of the all processes. So it's not only compressor by itself. We should to provide a lot of auxiliary equipment which allow us to test, like lifetime testing, performance testing, pressure proof, etc. And you see now this is the compressor installed in the inside of the performance test setup, and the testing is performing. And in reality, we perform during the 4 months. We extensively investigate characteristics of this compressor and provide to our clients full picture how it is worked. And they are quite confident that this compressor is mature enough technology to go further. Also, during the testing, it was very long, sometimes days and night testing. We measured a lot of parameters, and all this software was also developed inside of our company. So, of course, vibration. It is crucial for space applications, and one of two of the compressors go to vibration to Bremen, where we perform this task successfully and demonstrate what we sustain all these enormous loads which will be during the launch. And this is the just test result, what we put in the graph, just for, and we get full characterization of the compressor, and we can predict how much and how quickly we can pump from one tank to another tank. And this is very important now for modeling of operation of such type of the compressor. And this is the real operational case, for instance, which we consider it when we are pumping from the source tank to the client tank, some amount of the xenon, and you see the compressor which we deliver it is capable in average pump 2.47 grams per second. When we had specification 1.5. So from this point of view, our client are happy because we reached their goal, even significantly overcome this goal. So as a conclusion, this xenon development project requirements have been fulfilled, and developed technology performs as expected. Several engineering models has been built. 4 principal test setup in numerous manufacturing and testing processes, procedures, tooling, equipment were developed during these 2 years. This technology reached level 6 and tested in relevant environment where it demonstrate capabilities to perform at required xenon pumping rate. And the technology is considered to be mature enough to advance to next qualification model stage. So probably it was too technical, I may be sorry, but it shows you the way what we done to reach qualification level. For us, it is great success because it was a lot of efforts, a lot of up and down, but we reached the aim. Okay, thank you.
Thank you very much. Each space business starts with technology, and of course it's important, and there are people who will be maybe in the future interested in this information. Everything will be recorded, and you can reach it on the Deep Tech webpage. Are there questions from the audience? Yes.
Hello, Lev Lapkis from Allatherm Electronics. Thank you for the presentation. It's great technology. So my question is, so for technological company from Latvia, it's a problem for a maiden flight, so for us to have a space heritage. What do you think would be your steps in order to have like first flight into the space in order to be notified by many other companies? And maybe second question, what is a market? Because there is no many such missions where you need external refueling. What do you think the future there will be more, or there will every decade one big mission like Lunar Gateway or something like this?
Yeah, the answer is first, to reach the next level, we have to go to qualification and to flight. And it seems like it is on the way because this technology started from TRL 1, and now we have on the 6, and we have strong support from the prime contractor, which is OHB. And that's why I think we're quite secure, because there are no competition actually, because we reached the already high level. So with this technology, it seems like we have real huge chance to reach the space. Same with another one. Also, it is possible to reach the space even on the same missions. Now about the second question. Why OHB is so interested in this technology? Of course, it is good for this space station. But in reality, today in space, we have a lot of satellites, telecommunication satellites, which have the xenon as a propellant. It's not small amount. And there are no possibilities to recharge. That's why in 15 years, satellites go out, not because it cannot work, just because there are no fuel. If there are technology of the refueling will appear when the real commercial market will be opened, because now, due to Elon Musk, the launch by itself is not so costly. It means it's better to recharge than to build a new satellite. That's why there are quite good commercial interest from this point of view.
Thank you. Another question?
Yeah, hi, my name is Artem. I'm from Mission Space. A short question. First of all, that's amazing, the technology you built from scratch. Wow, and I guess my question is, when do you expect to actually finish the project and deliver the tank to the end customer? What is your projected timeline?
It is 3 years.
3 years?
3, maximum 4, but it depends how a Spirit program will move. So we already have some, for instance, request for information. We understand where they will need this one, but it may be 4 years to reach the space.
Thank
yes,
you.
Good
realistic.
luck.
Good luck. This is amazing.
Okay, thank you.
Thank you. Very impressive.
Thank you.